Huawei has taken a bold step into the future of electric vehicle technology with a newly filed patent for a sulfide-based solid-state battery. According to the company, this battery could deliver a staggering driving range of up to 3,000 kilometers, or 1,864 miles, on a single charge and reach full capacity in just 5 minutes. These claims, if realized, could address two of the most persistent challenges in the EV world: limited range and long charging times. At the heart of this innovation is an impressive energy density, estimated between 400 and 500 watt-hours per kilogram, which is roughly 2 to 3 times higher than what conventional lithium-ion batteries currently offer. In this video, we'll break down Huawei's new battery technology, how it compares to others in development, its advantages and drawbacks, and what we know about its potential cost and release timeline. Just a reminder to hit the like button and subscribe if you enjoyed this video. Solid-state battery technology has long been hailed as the holy grail of energy storage. Unlike traditional lithium-ion batteries that rely on flammable liquid electrolytes, solid-state designs use solid materials. This not only makes them safer, but also allows for more compact and energy-dense configurations. Huawei's patent builds on this concept using sulfide-based electrolytes, a choice that comes with its own set of benefits and challenges. Of course, Huawei isn't the only player racing to develop next-generation battery technologies. Major global companies like Toyota, Samsung SDI, QuantumScape, Solid Power, Panasonic, CATL, BYD, and LG Energy Solution have been investing heavily in solid-state battery research. These efforts are further supported by academic institutions, including the University of Missouri. This is where researchers are focused on solving some of the critical scientific problems that still limit solid-state performance, such as interfacial instability and short lifespan under repeated charging cycles. In China, which is Huawei's home country, the broader technology and automotive sectors are deeply involved in material innovation and scaling up advanced battery manufacturing, positioning the nation as a key player in the global battery race. The potential benefits of Huawei's new battery design are, honestly, pretty significant. One of the most striking features is the high energy density, which could enable electric vehicles to travel up to 3,000 kilometers without needing a recharge. This would eliminate the so-called range anxiety that discourages many drivers from switching to electric vehicles. On top of that, the battery is designed to be ultra-fast charging, reaching full power in just about 5 minutes. If achievable in real-world conditions, this would bring EV refueling times on par with, or even faster than, traditional gasoline fill-ups. Safety is another area where solid-state batteries have a clear edge. The elimination of flammable liquid electrolytes reduces the risk of fires and thermal runaway, a concern that has plagued some lithium-ion battery systems. Huawei's battery also aims to overcome common limitations, such as capacity degradation over time. By addressing the interface issues between solid materials, the design could extend the overall cycle life, allowing vehicles to retain their range and efficiency over many years. Moreover, with higher energy stored in less physical space, the battery packs can be made smaller and lighter. This contributes to better vehicle performance, improved efficiency, and potentially lower overall weight, which further extends range. Despite these exciting possibilities, there are still several major hurdles to overcome. One of the biggest is that the cost of the sulfide-based electrolytes used in Huawei's battery is extremely expensive, sometimes costing more per gram than gold. This makes the initial production and early versions of the battery prohibitively expensive for mass-market EVs. Additionally, manufacturing these batteries at scale remains a significant technical challenge. Solid-state systems can suffer from uneven lithium plating, dendrite formation, which can short-circuit the battery, and brittleness in the solid materials, all of which complicate the assembly process and affect reliability. Even though lab results may be promising, transitioning from controlled experiments to factory-scale production is a different and much more difficult task. Furthermore, while solid-state batteries have made significant progress in recent years, the technology is still in its early stages. Many scientific and engineering challenges remain unresolved. especially those related to consistent performance across a broad range of operating conditions, durability under repeated charging cycles, and stable performance at high energy outputs. These issues are particularly critical for automotive use, where batteries must withstand extreme conditions and years of usage without degradation. At this point, Huawei has not released any official pricing details or a specific commercial launch date for the battery. However, industry analysts believe that solid-state batteries, especially those using costly sulfide electrolytes, will continue to carry a premium price for the foreseeable future. That said, costs are expected to decline over time as the technology matures and production scales up. Still, even with future cost reductions, these batteries are likely to remain more expensive than today's lithium-ion options in the near term. In terms of availability, Huawei's innovation remains in the development and patent phase. While the announcement has sparked excitement and intensified competition in the battery space, a commercial rollout is probably years away. Experts predict that widespread deployment of solid-state batteries will begin sometime between 2026 and 2030. Early applications are likely to appear in premium electric vehicles or niche markets, where performance advantages can justify the higher cost. Mass market adoption may take longer, depending on how quickly manufacturing, cost, and reliability challenges are resolved. Huawei's timeline will likely mirror this broader industry trend. In summary, Huawei's new solid-state battery patent represents a potentially transformative moment in EV technology. With its extraordinary claims of ultra-fast charging, long range, and improved safety, the battery holds the promise of overcoming some of the biggest obstacles that have limited EV adoption. However, as with many emerging technologies, the road to commercialization is filled with complex challenges, from high material costs and manufacturing difficulties to unresolved technical issues. As Huawei joins a global field of ambitious companies and researchers, the world watches closely to see if this breakthrough can deliver its promise and help usher in a new era of clean, efficient, and powerful electric vehicles. Before you go, check out some of my other videos. Don't forget to hit that like button and subscribe. Thanks for watching. We'll see you at the next one.